This is the 5th chapter of class 11th, states of matter. Now, there are 3 states of matter: solid, liquid and gas, which we are studying from lower classes. Now, on the basis of class 11th, we can call them as: a substance is said to be solid if its melting point is above room temperature. Melting point is above room temperature, then it is called as solid. If its melting point is below room temperature, then the substance is called as liquid. And if a gas, its boiling point is below room temperature, under atmospheric pressure, then it is called as gas. Once again, solid has melting point above room temperature, liquid has melting point below room temperature, and gas has boiling point below room temperature. Now, there is a term triple point. The temperature at which all the 3 physical states, that is solid, liquid, gas, exist together is called triple point. For example, water exists in all the 3 physical state: ice, solid state, then water, liquid and water vapor gas at 0.01 degrees centigrade. 0.01 degree centigrade and 4.58 at atmosphere or mm pressure. 1 atmosphere is equal to 760 mm pressure होता है, तो 4.58 mm pressure is called triple point. Now, there are some properties on which we can differentiate solid, liquid and gas. In solids, molecules are closely packed, they cannot move, whereas in the case of liquid, molecules are less closely packed, whereas gases, they are far apart. Intermolecular forces in solid strongest, in liquid weaker than solid, and in gas almost negligible force of attraction. Density in the case of solid is high, in liquid it is lower than solid, and gases lower than liquid. Now, the position of molecules in solid are fixed, so they do not have any rotatory or translatory motion, but they vibrate at its position. They vibrate at its fixed position, then they are called as solid. In liquid, molecules are free to move both ways, translatory as well as rotatory, and they also moves at their position as well as सीधे आगे पीछे कैसे भी घूम सकते हैं. In case of gases, they are extremely free, there is no force of attraction, so they are free to move. Next point is solids. In solids, molecules possesses least energy, most stable, so least energy, higher than solid, and gases are most energetic, आराम से खूब तेज़ी से घूमते रहते हैं, आपस में टकराते हैं, एनर्जी की जो है एक दूसरे को ट्रांसफ़र करते रहते हैं. Solids have definite shape and definite volume, whereas liquids do not have definite shape, but they have the shape or the volume of the container. And gases, they neither have shape nor volume. Solids possess least compressibility factor, दबाएंगे दबेगा नहीं, and thermal expansion, but in the case of liquid they have slightly higher than the liquid, and in gases both, that is compressibility factor as well as thermal expansion is very high. Now, intermolecular forces, as the meaning of the word, that is, it is the force of attraction between the molecules of any substance are called intermolecular forces. Means suppose this is the molecule and this is the second molecule, the force of attraction which binds the two molecules is called intermolecular force of attraction, and greater the intermolecular force of attraction, higher is the boiling point. That is why we say that ionic compound have higher boiling than covalent compound, because the ionic compounds have electrostatic force of attraction, whereas covalent compounds have weaker than the ionic bonds. So we can easily break, so less boiling point. Now that is why the boiling point is higher, because we require energy to break the bond. Heat is absorbed from outside to break the bond, therefore the that is boiling point will be higher. So greater the intermolecular force of attraction, greater will be the. Now there are many types of intermolecular force of attraction, but in class 11th we have to study 4 types. The first is dipole-dipole interaction. Now if suppose two molecules are there which are polar in nature, then they have small dipole moment among the molecule only, and when these two molecules are placed side by side, the negative charge of the one molecule attracts the positive charge of the other molecule. So here we have taken the example of HCl. Cl is more electronegative, so this it attracts a shared pair of electron towards itself, requires or acquires partial negative charge, whereas H requires partial positive charge. Similarly second molecules also, and so this small charge attracts the partial positive charge of the hydrogen. So this is called as dipole-dipole attraction. Similarly we can take the example of HF. Now here, so this is this force of attraction between these two is called dipole-dipole attraction. Now the dipole-dipole interaction depends upon electronegativity and geometry of the molecule. Now electronegativity, that is greater the electronegativity, more will be the dipole moment, so more will be the dipole-dipole interaction. So I have given you an example, that is HF and HCl. If we compare this, so HF molecule, this F is more electronegative than Cl, so the dipole-dipole interaction between HF molecule will be greater than HCl molecule. Now second is geometry of the molecule. We have studied, that is ammonia. Its structure is pyramidal, so there will be a repulsion between bond pair and lone pair, so that will also result in the dipole-dipole interaction. जितना ज़्यादा जो है bond angle कम होता जाएगा, उतना ज़्यादा जो है आपका dipole-dipole interaction जो है घटता जाएगा. जैसे HF में bond angle 180 डिग्री है, ये इसका जो है dipole-dipole सबसे ज़्यादा है. इसको जो है इन्वेंट किया था एक साइंटिस्ट से कीसम in 1912. It is also called as orientation effect. Second type of intermolecular force of attraction is dipole induced dipole interaction. Here one of the molecule will be polar and the second molecule will be non-polar. Means a non-polar molecule, when is brought near the polar molecule, then due to the dipole moment of the polar molecule, this symmetrical electron cloud of the non-polar molecule gets distorted. मतलब कि noble gas क्या है, non-polar है. इसको अगर हम एक पोलर मॉलिक्यूल, कोई भी एग्जाम्पल ले सकते हैं आप, NaCl ले, कुछ भी ले लीजिए, इसके जब अगर हम नज़दीक लाएंगे तो जो है ये पोलर मॉलिक्यूल इसके इलेक्ट्रॉन क्लाउड को अपनी तरफ अट्रैक्ट करता है। तो मतलब कि इस पोलर मॉलिक्यूल ने इंड्यूस किया इस नॉन पोलर मॉलिक्यूल के अंदर जिस फोर्स ऑफ अट्रैक्शन को, उसको कहते हैं हम लोग डायपोल इंड्यूस्ड डायपोल इंट्रैक्शन। और इसकी स्ट्रेंथ डिपेंड करती है डायपोल मोमेंट पे। जितना ज़्यादा डायपोल मोमेंट होगा पोलर मॉलिक्यूल में, उतना ही तेज़ी से वो नॉन पोलर मॉलिक्यूल को अपनी तरफ अट्रैक्ट कर पाएगा। तो ये हमने एग्जांपल लिया, नोबल गैस है हीलियम, और हीलियम को हमने NaCl मॉलिक्यूल के पास रखा तो इसको अट्रैक्ट किया, तो क्लाउड कुछ इस तरह से आपका ये जो फोर्स ऑफ अट्रैक्शन रहता है, so that is called dipole induced dipole interaction, and this was discovered by Debye in 1920, also called as induction effect. Now third type is dispersion forces or London forces. The force of attraction arises due to the motion of electron. London forces arises due to the motion of electron. It is believed that the electron cloud of the molecule may be distorted. It is believed that the electron cloud of the molecule may be distorted, so the instantaneous dipole is produced, in which one of the part of the molecule gets slightly more negative than the rest. जैसे आपका ये है, देखिए एक हीलियम मॉलिक्यूल है,